Of absolute maximum points for the graph of each function. How are these features related to the degree of each function? All right, I think they just want us to match. So let's take a look at the first one. We know the first one is odd. So an odd of 3 can either have x-intercepts of 1, 2, or 3. Possible x-intercepts, we know that. We know that number of turning points can be 0 or 2. Because remember, if it's an odd value, you do n minus 1, 2. So maximum value is 2 turning points. But you can also have 0 turning points. So anything lower than that, that's even. So if you have 0 or 2 turning points, that means that is also your local max or min. Remember, turning points are the amount of local max or min. So we can have either 2 local max mins or a 0. So let's see. Let's see if we can figure that out. So we have 3 turning points. So we know it can't be A can't be this one. We know this is 1, 2, also 3 turning points. So it can't be this one. This is 1, 2, 3, 4 turns. So it can't be this one. This has 2 turning points. So it's possible that it's that one. It also has 3 x-intercepts. So once again, 3 x-intercepts, 2 turning points, very possible. And it's a positive leading coefficient. So that means it is going the proper way. So I would highly think that this matches up with this one here. And did I answer everything? Let's see. Yeah, Exodus we did. Yeah, number, yeah, we did. Absolute max. Okay. Okay. This is degree of friction. Okay, I'm not sure what the last question is asking. We'll look at the answer in a bit. I think they just want us to match, right? All right, so B, this is even, so 4 is even. So the number of turning points is either 1 or 3. And then x-intercepts can be 0, 1, 2, 3, or 4. And we know the leading coefficient is negative. So since it's negative, that means kind of like this. So y has to go to negative infinity, and y has to go to negative infinity while x is doing its thing. Yes, it's kind of like going downwards. So which function is going downwards? We know that this function is going downwards, this function is going upwards, and this function is kind of going across. So I would highly consider this one because it has 3 turning points, which is the amount that's allowed. It has 1, 2, 3, 4 x-intercept, which is allowed. So I would think our second graph for B would match up. Sorry, our equation for B would match up with the first graph. So yeah, I'll just write B. All right, so we're done A and B, and then we're left with C, which is x to the power 5. So that's odd. That's 5. We know 5 means 4 turning points, but it could be 0, 2, or 4 turning points. And we know x-intercepts has to be at least 1, and up to the maximum value of the degree, so 5. And we know it's a negative leading coefficient, so our normal kind of odd degree function goes like this. So since it's negative, it's going to be the opposite of that. So it's kind of going to go like this. So from quadrant 2 to quadrant 4, 2 to 4, Q2 to Q4. So which one of these is going from Q2 to Q4? And there's only one of them that's doing that, and that's this one here. And this is the only other one that's odd. And it has 1, 2, 3, 4, 5 x-intercepts, which is possible. And it has 1, 2, 3, 4 turning points, which is possible. So yeah, highly think that this is C. And then the last one, I mean, we don't really have to do it, but I'll just quickly go over. It's pretty straightforward. So x6, that's even. We know it's even. We know it has it's got to be positive. Leading coefficients has got to be from 2 to 1. So it's facing upwards, and yeah, it's D. Okay, and let's take a look at the answer. I think I did it right. Oh wow, there's a lot of answers here. The function is cubic, positive coefficient, graph extends, y-intercept is this, and graph 4. Yeah, so basically everything that I said, they just wrote it. So just, oh, sorry, I didn't mention the local max and mins. I just counted a turning point. So, I mean, you can just see that it's either 2 local maximums and 1 local min, so 3 turning points. Oh, they did talk about turning points actually. Sorry, I did do that. Okay, yeah. Okay. So yeah. So the absolute max point is just the points that are when your local max or minimum is one of your absolute max or minimums as well. So that's that. And this is very common. The function has no absolute max or min points. What that means is when the function goes to infinity, then it has no absolute max or min points. So like this function here on 3, this graph, there's no absolute max or min. 4, there's no absolute max or min. For question number 2, there is an absolute min because it doesn't go below this point, and for question 1, there's an absolute max because it doesn't go higher than this point. So just yeah, that's something you should know. I think yeah, and that's it for our live class. I think we finished. We'll go over that later maybe. But yeah, hope you had a fun time. I will be staying back a few minutes just for Q&A if anyone has any questions. Other than that, yeah, good luck on your quiz that's due on the 19th.